Next problem we have, we're given a lot of information and we're actually given the answer just to verify that everything that we do is correct. First of all, we are given that a 15 centimeter diameter aluminum ball is to be heated from 80 degrees Celsius to an average temperature of 200 degrees Celsius. So two things here. One is that we're given the diameter, which is 15 centimeters. I know I'm going to be using meters, so I need to divide this by 100. In doing so, I'm going to get 0.15 meters. Not only that, but I will be needing the radius, which means that I need to divide this by 2. And if I do that, I get a radius of 0.075 meters. Change in temperature, it's equal to final temperature minus initial temperature, which is 200 degrees Celsius minus 80 degrees Celsius. If I do that subtraction, I get that change in temperature is 120 degrees Celsius. Now, I am going to say that this is actually 120 kelvins. Reason for that is in one of my previous video. Go ahead and take a look at it. I am not going to go over that just because it's going to take a bit longer than what I want for this problem. Another thing that we're given is that the density, it's 2700. So density is equal to 2700 kilograms per meter cube. And also the specific heat is equal to 0.90 kilojoules divided by kilograms times kelvins. This is the reason why I'm gonna change this 120 degrees Celsius to 120 kelvins. And not just because I'm not changing it just because it's gonna benefit me. There's a reason behind it. And again, go take a look at the video, the video that I posted a couple of days ago, and you should be able to see that. Now, what they want us to do is that they want to, for us to determine the amount of energy heat. Again, just like I keep saying, this here is going to be the key word for what they want us to find, the amount of energy. We know that we have this formula. Q is equal to mc delta T. We have the change in temperature. We have specific heat. The only thing that we don't have is the mass. But we can actually find the mass by using density. We know that density is equal to mass divided by volume. Okay. I want to isolate the mass. In order to do that, I need to multiply by volume, both sides of the equation. If I do that, volume cancels out. And so then I end up with mass is equal to volume times the density. One thing that I do need to write in here is the formula for the volume of a sphere. And that is volume is equal to 4 pi r cubed divided by 3. Okay. I can plug that in there. I could just find the volume separately. Doesn't matter. So actually, let me move. No, I think it should be okay. So then, volume is just going to be 4 pi. Radius, like we say, is 0.075. That is meters. I like to work with my units. Cubed all over 3. Once I plugged all of this into calculator, I end up getting the following value. And you guys can do this your calculator as well. So need a little more space. So my volume is going to be 0 0.0 0 17671 So I'm gonna write as many decimals as possible. Okay. Now I can actually find the mass. So the mass is just gonna be mass is equal to the volume, so that is 0 0.00 meters cubed. 17671.459 meters cubed, and density, we know that is this much, so that's 2700 kilograms per meter cubed. Now what happens here is that the units cancel, meters cubed cancel out, and I end up with kilograms, which is what I want. Again, plug that into the calculator. And then when you do that, you end up with 4.7. And I'm gonna write pretty much all the decimals that I get, or the entire numerical answer. So it's 4.7, 7, 12, 93, 93 kilograms. So I just found the mass. Now I can go and plug everything into this formula to find the amount of energy, which I'm gonna do here. I have more space down here, so I'm gonna have Q is equal to mc delta T, or Q is equal to the mass, which is 4.77129393 kilograms, and specific heat, it's 0.90 kilojoules divided by kilograms times kelvins, and change in temperature is 120 kelvins. I can now cancel the units, so kelvins cancel out, kilograms cancel out, and I end up with kilojoules. You put all of that into the calculator, and what you're going to get, it's the 515 kilojoules. Actually, if I wanted to write all the decimals, I end up with 515 .2997 kilojoules. But since I just want the answer as that, I'm just gonna put that is just 550 kilojoules, and that is the answer to that.